Okay guys, let's have a look at 7 then. It's to do with logs, so we need to know our properties of logarithms on this question. So find all the values of x satisfying this equation here. Log a of 6x squared plus 11 minus log a of x equals 2 log a of 5. Okay, let's go to our notepad then. And that's 11 there. So it's log a of 6x squared plus 11 minus log a of x is 2 log a of 5. So right, the way I'd do this is minus, so it would be this log of something minus something. You can write that as a divide of one over the other. So I can write this as log a of this divided by that. So let's just do that, shall we? So that's the left-hand side. The two lots of, basically it came from up here, 5 squared, because when anything in the air jumps down to ground level to be there. So you can reverse that process by writing log a of 5 squared. Okay, so, and that's 25. So you can read off, because the log of these values are the same, you could read off that. Which is probably the best way to do it. Yeah, so because this log is equal to that log, this value is equal to that value. I won't go into, there is another way to do it as well, but let's not do that. So we can just simply, because their logs are equal, the values themselves must be equal. So simply we can write 6x squared plus 11 over x is equal to 5 squared, which is 25, yeah? Move the x up, equals 25x times by x, both sides, and then move the 25x over to the other side, minus 25x plus 11 equals 0. Okay, let's just try and factorize it then, because 11 only goes into 11 and 1. So, excuse me. So how many x's and how many x's? 3 and 2? Doesn't look like it. What about... No. 3 and 2. Ah, yeah. Yeah, I see it. It's a bit awkward, that one. 3 and 2 it is, but it wasn't the 3 11s and 2 1s, because that wouldn't reach 25. But it would be 2 11s and 3 1s, wouldn't it? Because that makes 25 when you add them together. So if we do the 2x with 11, we'll get 22, and the 3x with the 1, and if we do a minus and a minus, so we get 6x squared minus 22x minus 3x is minus 25x when you combine add them. And then the last one is minus times a minus is a plus. It takes a bit of thinking about that, actually, because you wouldn't think of that straight away, I don't think, because you'd try and do the 3 and the 2 around the other way, which wouldn't give it. But there is that other way around as well. Good. Okay, then that's that done then. So that equals 0. So that equals 0 when either 2x minus 1 equals 0, or it happens when 3x minus 11 equals 0. This one happens when 2x equals 1 if you move the 1 over. And this one, if you move the 11 over, you get 3x equals 11. Divide by 2 both sides, x equals a half. And this one, divide by 3 both sides, x equals 11 over 3. Okay, so that's what we get as our answers then for question 7. And that's that done. So, quite an awkward problem that, because the logs were not easy. And this observation here, these values must be the same because the log of them is the same. So we could write down that. So that's not too bad actually. This is a quadratic. And then 11 and 1, it had to be here and here. And then the 6, well it wouldn't be 6 and 1 because that's impossible. So it had to be 2 and 3 or 3 and 2. And then when you tried 3 and 2, you would think of putting the 3 with the 11 to start with. And the 2 with the other value. The 2 with the 1. But that wouldn't give you 25. So you're forced to try the 2 and 3 as the only other possibility. And when you do, you realize, yes, it will work because look, 6x squared, that one, minus 22x minus 3x, which gives the minus 25, and then minus times a minus is a plus. 11 ones are 11. So either this is 0 then, or this is 0. That's when the product will equal 0, and these values, either of these is 0. Move the 1 over, divide by 2, or move the 11 over, and divide by 3, and these are the two answers. We're fairly optimistic that they're okay. So good, that's question 7 done then. Great, let's go on to the next one.